Alright, so now that we have a little bit of knowledge of what kind of shapes we're expecting when it comes to quadratic functions, we're going to get down more to how to identify the characteristics. So what characteristics we really care about? Well, we're going to start with the axis of symmetry. And we talked a little bit about this already. You should have some kind of experience with it. But this idea of the axis of symmetry is always a vertical line. So you may be asked to visually identify an axis of symmetry. And so the axis of symmetry, you just need to remember, is that line that we would take, that vertical line, and it'll always be a vertical line, that we can take and fold our parabola onto itself, acts as a reflection. Where I place the mirror, if it would reflect over and form the full parabola. So the thing is about finding the axis of symmetry, I may ask you to do it visually from a picture, but what we really want to be able to do is find that axis of symmetry based off of the equations. So here we see a few equations and their actual graphs. If I asked you to graph these, this is kind of generally what they would look like. And how we find the axis of symmetry, the value for the axis of symmetry, is actually, we're going to fill in this table to kind of help us out and figure out what that equation would be, because actually what we want to do is find the equation of this. And if you remember a vertical line, if you remember the saying "Hoy bucks," a vertical line always has an undefined slope, and if you remember, the equation is x equals. So when we find the equation of the axis of symmetry, which you may be asked to do, it's going to be x equals a number, and in this case, what's the value of x equal to? The vertical line here would be x equals 3. So how do we find that from an equation? Well, this table is kind of suggesting to us what to do. So the a value for this first equation is 1. The b value is -2. If we take b over a, -2 over 1, we get -2. Okay, so that may not be very helpful to us right this second, but let's fill in the second one here. From what we can fill in right now, the value of a is -2. The value of b is -8. b over a is -8 over -2, which is 4. And then what's the value for our axis of symmetry from the graph? It's x equals, and this value is -2, so it's x equals -2. For our last one here, the a value is -1, the b value is 4, so b over a, 4 over -1, is -4. And from the graph, we can see that our value for our axis symmetry is x equals 2. So what you're looking for is there a pattern here as I go from this b over a value to the axis of symmetry. Hopefully you see it, but what we can say is if we wanted to actually calculate and find the axis of symmetry, if you notice, you take this number and if you divide it by -2 each time, you actually come up with a value for the axis of symmetry. So identifying the axis of symmetry is merely about noticing, you don't have to do the graphing, is noticing that relationship. So in general, here's your rule. The axis of symmetry is found by, it's always x equals, because we said it's a vertical line, it's always going to be a vertical line. And how we write that, instead of saying b over a divided by -2, which you could certainly do, we list it as, it's generally written as -b divided by 2 times a. We're saying the same thing, divide b and a, and then divide by a negative and a 2. But what you may notice is this -b and this 2a, does this look familiar from anything else? It's actually part of the quadratic formula. So if we're going to find the axis of symmetry, we need the b value, which is -6. We need the a value, which is 1, when this is written as y equals, in standard form here. We can find the axis of symmetry by taking the b value divided by 2 times, whoops, the a value, which is 1 in this case. So negative negative 6 is 6, divided by 2 is 3. So finding the axis of symmetry, so if this was a parabola, our axis of symmetry would be at x equals positive 3. So why don't you take a try on this one? So the axis of symmetry is negative the b value over 2 times the a value, negative 10 over negative 6, negative divided by a negative, positive 10 6, and then simplify that fraction, so 5/3. So our equation for our axis of symmetry is x equals 5/3, or x equals, you could put 1 2/3 if you would like. So finding that axis of symmetry is kind of our starting point, and we're going to kind of go in order here for identifying the important characteristics of a parabola. Off of that axis of symmetry, if you notice visually, the vertex, that minimum or maximum point of a parabola, so here we have our parabola, here would be our vertex. What we notice is that no matter how that parabola is oriented, so there's my vertex again, the axis of symmetry is kind of your starting point when it comes to finding the vertex. Because the vertex is always that point that the parabola is going to be folded, can fold onto itself. It's that symmetry point, that axis of symmetry is always going to go through the vertex. So when we talk about finding this value, and I'm actually going to go to the next slide so you can see it. When I look at finding the vertex, which is a point, the maximum or minimum point, depending on how your graph is oriented, what I'm really looking for is, okay, what's the x value and what's the y value? I'm looking for what are the coordinates of this point. So if you think about the axis of symmetry here, and if we identified the axis of symmetry here is x equals 3 visually, what do I know about this point? Well, this point is 3 comma, and then we can look at the graph here and we can see that the vertex is 3 comma negative 8. But the starting point for us is actually, when it comes to finding the vertex, first thing we want to find is the x coordinate, which is the same as the axis of symmetry. So find the x coordinate of the vertex. We're going to take negative b over 2a. It's a point. If you remember, the vertex is a point here. It's the maximum or minimum point. It's an x and a y. So how do you find the y coordinate when you know the x coordinate? So to find the y coordinate, you're just going to plug x in. So if we see this in action on this particular one, doing it from a graph visually, just seeing where's the minimum point, where's the maximum point, but doing it visually from a graph, we want to find the x coordinate and we want to find the y coordinate and answer as a point here. So the x coordinate, how do we find that x coordinate? Same way you find the axis of symmetry. It's negative b over 2a. So it's negative 4 over 2 times 1. So it's positive 4 over 2. So it's positive 2. So my point is 2 comma, and to find that y value, I'm just going to take that 2, that x now that I know, and plug it into the equation. So it's, and notice I'm putting parentheses around anywhere I plugged in. If it's a negative number, it really, really matters. But 2 squared, 4 minus 4 times 2, 8 minus 10. So 4 minus 8 minus 4 is negative 14. So identifying the vertex involves a little bit of the same as axis of symmetry, and just using knowledge that we've seen before to get that y coordinate. So the vertex at minimum or maximum point, negative b over 2a, and then plug in. So I want you to try this one. So the x coordinate is negative b over, over 2 times a. So it's 10, positive 10 over positive 10, which is 1. The y coordinate, to find that, plug into the equation. Plug your x value into the equation. 5 times 1 squared minus 10 times 1 plus 3. So that's, remember, do the exponent first for PEMDAS here. So 1 squared is 1, 5 times 1 minus 10 times 1 plus 3 would be negative 2. So your vertex here would be 1, negative 2. So if we look at our graph, 1, negative 2, and then our parabola would go something like that. So we're getting kind of more, we're just doing kind of building blocks here. We want to get more and more information about the parabola for this equation. We're going to start doing these kinds of problems more later in the week, but I did want you to get an opportunity to see how parabolas are actually very useful to model different things. And one place you might see a parabola is actually in looking at arches. And arches, in this case, there's a bridge. So if you are looking at, here's the equation for this arch based on where the axes have been placed here. X is the distance in feet, so you might want to label it the distance in feet from where the arch support enters the water, so from here. And then the y value would just be the height of the bridge here. So the question is, can a sailboat that is 24 feet tall pass under the bridge? Hopefully, I mean, this is a you do, so I want you to kind of think of this on your own, but if you need some help, then by all means continue to just let this play. Where's a sailboat going to pass under? You think about this. The sailboat's going to want to pass under the highest possible point that it can. So in other words, can the sailboat fit under the vertex? So what I need to do on this parabola, and I know this equation isn't so pretty, what I need to do with this parabola is find the vertex. So take negative b over 2a to find the x coordinate. Where's this vertex? So negative b over 2a, negative 0.84 over 2 times negative 0.007. And I'm going to need my calculator for that one. Negative 0.84 divided by 2 times negative 0.007 is 60. Thank goodness that works out nicely. And the y coordinate, negative 0.007 times 60 squared plus 0.84 times 60 plus 0.8. I would again suggest typing this into your calculator. Negative 0.007 times 60 squared plus 0.84 times 60 plus 0.8 is 26. So this vertex is at 60, 26. By the way, double check those numbers on your calculator to make sure you can get them as well. So what do these represent? This represents the height, or sorry, the distance away from the entering point, and the 26 represents the y value, represents the height. So can a sailboat fit under there if the sailboat is 24 feet tall? The answer is yes, because the vertex is 20 at 26 as far as the height goes. So finding the vertex and finding the axis of symmetry are kind of your basic starting points when it comes to a parabola. We'll practice these and use these to answer some questions and look at more characteristics in class tomorrow.